Hey, hello. Great to see you guys. Thank you for coming, especially on the last day of conference. So, my name is Frank Radecki. I'm a senior lighting artist at Bloober Team. I started my journey as a concept artist. Then I switched to level art. Now I'm doing lighting. So that was quite of a journey. Unfortunately, I don't have much time to cover this topic today. Today, I'll be talking about lighting in Unreal, about free workflows, how to set your lighting, your external lighting, your atmosphere correctly on your level. So I want to start with atmosphere components that Unreal gives us to light up our scenes. Those are all the stuff that's in Unreal you can light up the scene with. It's directional light, skylight. Actually, it might look really messy here as you got all of those on the one slide. So I tried to group them up and I did some cool colors. So now I will go briefly about those. So the lights, the directional light, the skylight, those are the lights that light up our scene. We got the sky domes, the sky atmosphere, and sky sphere. And we also got, I like to call it glitter on top, so the stuff that makes our atmosphere looks even better. And there is post-process at the end. It's the last thing we actually always want to use, and I will explain later why. So, explaining those stuff, the first thing, directional light is, as the name says, directional light. The one really strong source of light on our scene. The second one, and the reason why it's not skylight, I will explain in a second. So we got sky atmosphere. As I said, it's a sky dome, so it generates the our sky based on the directional light. We got skylight. And now you can see how skylight works. It would be hard without skydome. So skylight actually takes our sky and lights up the rest of the level with it. So here you can see the difference. With skylight. We got, of course, sky sphere. We can use it alternatively to sky atmosphere. There's not much to say about it. We get back to skylight to show you how the stuff changes. So now the fog, it's a glitter on the top, so it's not exactly a part of the lighting in the atmosphere, although it can also change it. Volumetric clouds, if you have too much FPS in your game, that's for you. And post-process volume. And actually, post-process volume does not change anything per se. I mean, you have to tweak some stuff to make it look like this, for example. You can do all of those stuff in post-process. So, in the subject of the presentation, I mentioned that free workflows for UE5 atmosphere creation. So now I will move to this part. So the first workflow you want to use for your atmosphere creation, you might want to use for your atmosphere creation, is Skybox-only workflow. As the name says, it's based only on Skybox. Of course, you can use glitter on top stuff. Unfortunately, not volumetric clouds, because they require sky atmosphere. But you can use exponential height fog, you can use post-process volume, and the effects should look like this. So, as you can see, simple HDRI lighting. There's not really much to say. You can see the components I used here. So it's skylight, it's sky atmosphere. Skylight is covering the scene with light. The sky sphere is covering the sky, so it's not black. So actually, sky is a lie, and what I mean by that is that you don't need to match your skylight with your sky sphere. So here, for example, there's the same skyboxes I used to light up the scene, but I turned off the sky sphere, and the scene is still light up. Here you can see the little breakdown of that. So the sky sphere, there's the shader. Actually, that's the shader that Unreal provides in the base stuff, in the starter content. So there's not really much stuff I did here. And I just add my cube map texture there. And you also got skylight. I put the same cube map there. That's the effect, how the scene looks. But I said you can put anything you want there. So the second workflow is directional atmosphere. And it's more physically based than the first one. The first one is based on the HDRI image you use. You can download, I don't know, from some website over internet. The second one it's based on the sky atmosphere component. And also, the difference between the first one and the second one is that we use capture scene skylight. So it's not a specific cube map, it's a skylight based on the lighting of the scene. So the effect of the second workflow might look like this. And at first you may think that there's not really much difference between the first one, as the scene is lighted. We see the light, we see the stuff on our scene. But the thing is that as our atmosphere is based on sky atmosphere, we can tweak those parameters to match the real world values, to match the real world effects. So actually, you can see that there's a lot of different stuff here that might look really unfamiliar for you or scary. But actually, there are 4 parameters that makes 90% of the effect. And those parameters are, sorry for my pronunciation, raylight, me, and absorption. And I marked them in red. Oh, sorry. So here's raylight, sorry. That's the first value. And raylight is a density of atmospheric gases. So if you want to achieve more, I don't know, like atmosphere or like on Mars or like on Saturn, you want to rise up this value. There's methane, that's dust and humidity, and absorption, which is ozone, and I will get to it in a second. So the first one, as I said, is raylight. Here you can see some effects, how it works with the scene. So if we make the value higher, there is more gases, the gases are more dense in the atmosphere. So the sun needs to travel, of course, like theoretical light from the sun. That's unreal. It's not a real world. So the light travels a little longer through the atmosphere, so it loses more of the bluish color, so it's more yellow. So if you want to create, as I said before, more yellow atmosphere, more dense atmosphere, or your scene just happening in Mexico, raylight is for you. There's a mist scattering. So mist is like really dense fog, or overall when the light of the sun comes through cloud. And of course, you can do it also by fog. So you can increase your volumetric fog amount on the scene. But as I said before, if you have too much FPS in your game, then you can do it. Me is just a simpler solution to that. So as you can see, we are scattering the light from the sun. And also, really important thing here is that you are losing the shadows. So the higher the me is, the less the shadows are visible. And absorption at the end, and actually absorption just absorbs one color from the atmosphere. So by default, it's green. You can see If I absorb green color, the atmosphere is more purple, and then I switch to and it's actually the opposite color. And all those three settings, I said at the beginning that those are 4 settings because I count the absorption as 2 settings because it's intensity and color of the absorption. So let's say those 3 settings, absorption, me, and highlight, is responsible for 90% of the effect. And we got the third workflow. And before I explain what the third workflow is, I need to explain how we, because that's the workflow I use on my daily basis, how we use it in, why we developed it. It's kind of nothing, like spectacular. We just added 2 to 2 and we got another one. So we wanted a little more artistic art direction over our atmospheres, over the skies and over the lighting on our scenes. So the problem with Skybox-only and directional atmosphere was that it was really hard, to give you a place to do something different. Because if you're using Skybox-only, you actually need to find a skybox or create it, and then you're lighting the scene with it. In directional atmosphere, you can of course use volumetric clouds. I'm not a huge fan of volumetric clouds, as you may realize, but volumetric clouds are really hard to art direct. So the combined workflow require a little of the additional system. It's not that much, that's just 2 nodes in shader. I will show it in a second. And we are actually combining the sky atmosphere workflow with the Skybox-only workflow. So it looks like this. Here are the effects. So as you can see, the sky is based on the overall lighting is based on skylight, directional light, sky atmosphere, and sky sphere. So it's the skybox is connected with the sky atmosphere. And where the magic is happening, it's right here in the shader of the sky sphere. So here you can see it a little on a bigger screen. So what I'm doing here, I'm actually taking the HDRI image and multiplying it by the, let's call it a color that sky atmosphere provides us. So all these sliders we use with the highlight, with the me, we are multiplying it by each other. We are adding sky sphere light distance luminance, and we are multiplying it by some value to make it brighter or darker, for higher art direction. And the effect, the best thing about the effect is that the sky, as you can see here, is working with the directional light. So the skybox you used is multiplied by the light with sky atmosphere, and it works perfectly together. So you can achieve really good looking effects, but just a simple solution. I think that looks quite good. And you're not using volumetric clouds, so it's a little cheaper. So here's a little sum up of all the workflows. It's not like the third one is the best one. I use all of them. All of those have their upsides and downsides. I'm getting ahead of myself, sorry. The Skybox-only, of course, is the cheapest one, but the minuses is really hard to art direct. The directional atmosphere, as I call it, it's difficult to set up an epic sky. So your lighting looks really cool, but if you're not using volumetric clouds, actually your sky is empty. It's just one color that you generate by sky atmosphere. And combined is the heaviest one, but it requires additional systems, but it gives you the highest art direction. So I also would like to talk a little about the post-process and the exposure, and why we want to use that. Just let me check the time. Thank you. So before I said that post-process, you always want to use the post-process because it's really important. And it's really important because you set your exposure there, your physical values there. What's exposure? I won't be getting too deep into the topic. So all you need to know actually is that it's an amount of the how wide or how thin your pupil in your eye is open. So on this scene, the amount of lighting is the same. The only thing that changes is the amount of the exposure. So, of course, in Unreal, we don't have eyes. We are using the camera lens. So, but it's kind of, it's working the same, kind of the same. So that's all you need to know about the exposure for now. But the problem appears when you want to light up your scene correctly. Because now, if you can set the amount of exposure, like any amount of exposure you want to in your scene, the problem is that you can actually set the same visuals for different exposures. So you can see on those two images, the light values are absolutely different. The 120,000 lux is something that actually sun lights up the Earth with. I mean, that's the, if you want to put the physical value for the sun, it's that the value you'll use. But one lux is, it's even darker than your phone screen. So what values do you use and why you use those values? So the thing is that you can actually you can solve this problem just using real values, real life exposure, real life values. And there's not much, I would say, philosophy to it. Just put over the internet how bright is, I don't know, like night lamp, or how bright is sun. And you get all the values. And if you're using the correct exposure, all those values will work correctly. I will have a showcase of that in a second. So here's where you set those stuff. You set it, as I said, in the post-process. You get min. There's this EV100 value. It's exposure value for ISO 100. What does it mean? It doesn't matter for you, at least now. But you're setting the min value and the max value. And this min value and this max value is how wide your camera lens or your eyes in real life is open and how thin it's closed. So I hope I understand, I hope I explained it correctly and you understand it. So here's a small show-off of this. So on this scene, there is auto exposure set. The min is set to, the min is so how the, in how dark environments we see stuff, and the max is in the how bright environments we see. So it's set to, the min is set 2, the max is set 15. And that's the effect you can see. So there's no change in lights on this scene. The only thing that's changing is the position of the sun, and as the sun goes through the horizon, through the sky, it has the stronger power, and there's much more light coming through it, and our eye, is adapting to it. So we got this effect that stuff is not lighted the same way. So if you're using it might be really hard if you try to use your own values, because it's really easy to mess up those. You need to get the correct proportions if you want to light up your level. And if you're using the physical values, you got all the right proportions. You don't need to think how bright the bonfire in your scene should be. You can just check it over the internet. It just works, as someone said. Yeah, so I will have one last thing. It's not really connected to creating the environment, but it's a thing that I usually encounter and people have some problem with that. That, like, despite like all the stuff I said before, the materials or your scene also matters. So if you want to use physically based values, or overall you're using PBR, you want to set your values correctly. Because no matter what atmosphere you're set, if your materials are broken, you won't see anything or your scene. And it will be too dark, too bright. Here on this GIF, you can see the scene, and the light of this scene is not changing. The only thing that changes here is the albedo value of those materials. So if you can see, if the value is above 0.85, the materials are reflecting too much light. That's impossible in the real world. And the material, if material is darker than 0.04, you cannot see anything. The 0.18 value is the value where the materials are reflecting 50% of the light. So it's, you know, like an average. That's all. Thank you very much. I think we have some time, so if there are any questions, feel free to ask.
Hi.
Hello.
Great speech. I have a question. Like when you about exposure, can you actually, or do you think it's even wise to art-directed exposure as well? For instance, when you have a game that only happens in night, so you actually don't need this eye adaptation to work with very bright light, and you don't know the values, like every value in your lights and in your materials to be 0.0 something, and you want to, you know, just to offset this, and you set your exposure really down. Do you think it's a wise idea, or does it generate problems and so on? Obviously, beside that, it's not physical already.
Yeah, okay, so I get one motto, first learn the rules, then break them. And that's something I do on my daily basis. So of course, what I showed here is, you know, like the basics, the stuff that's, okay, that's the rules. But of course, when we are creating games, you know, there are examples, there are moments then that we need to break those. So about the exposure, because that's also the topic I'm now kind of discovering about this art directing exposure. So the problem with that is if you art direct exposure, the lighting in your scene might be inconsistent through the different levels. But I would check at the beginning if you can kind of make the... I will try to find the lowest value and the brightest value that works for you. I will also try to set there are two values in Unreal that are responsible for how fast your eyes adapt to bright environment and dark environment. And I would try to make it, you know, as realistic as possible. And then if it won't work as you want, I would probably break the rules to make it. Yeah, I hope that answers your question. Thank you.
Hi, thank you for the talk. Another question about exposure. Do you know how Unreal handles auto exposure when you are quickly changing environments? For example, you're going through a tunnel and there's really, really dark there, but you're just here for a couple of seconds? Can you, okay, I'm rephrasing my question. Can you change the speed of auto exposure?
Yeah. As I said, yeah, there are two options. Sorry, I was not covering them. I was afraid I have not enough time, but wait a second, maybe I'll check. Oh, yeah. So here is speed up and speed down. So if you use those two, it's how fast your eye adapt to the bright light and how fast it adapts to the darkness. So that's basically those two settings.
Okay, simple. Thank you.
Thank you.
Hello, really great talk.
Thank you.
I wanted to ask you because I heard that the light behaves different in static meshes and with nanite. I know that the technique of, as a lighting artist, you have to approach it a little bit differently, also from 3D artist perspective. Do you have any tips on that?
Well, I mean, like, it's a really wide topic, you know. It's really nanite. You know that? What's your thoughts on that? I think if you can ask a little more specific question, I might answer. But also the thing is, I'm not a technical guy. I'm more artistic guy. I like my background is concept art, then level art. So I'm getting into technical stuff, but I might not be the best person to answer stuff about nanite and how it works, you know, like on the technical level with lighting. So I'm really sorry, but
thank you very much.
Thank you.
Hi there. Thanks for the talk. I want to double down on the changing exposure from going to the light, let's say outside environment to going inside the house. Would you recommend using auto exposure in this case, which gives you less control over the scene, or using two post-process volumes that one, for example, is very boxed to the place, but then there is this weird moment when you have to blend them, and sometimes the door is, you know, I mean, you can make the door wider, but
yeah,
the
exactly.
blending doesn't work that well.
So the thing that's kind of I would have the same answer as for the first question. I would try at the beginning to make it correctly, to set the values max like 15, min 5, because that's the amount mean exposure for interiors is about 5 to 7. So I would check how it works, and if it works, it should work. Like it's, you know, like if you're using physical values, the really cool thing about it is that you don't need to really think about all the cases, all the possibilities, because it works in those cases. It just works. But if somehow it won't work, because, you know, like there are different cases. Maybe you want to do it at night. Maybe there is like really specific atmosphere. Then I would use to post-process. So I think we don't have much more. I hope this answers questions. Yeah, I think we don't have much more time. So if you want to catch me, talk with me, I'll be somewhere outside. I'm for 3 hours here. So thank you very much once again.